Hello, Mr. Eric, Mr. Ryan, are you alright?
Hello.
Okay. So remember we talk about the multi, finding the multi in the array, right? The multi 1, 3, 5, 3, 0. So look, it's increasing and then decreasing. Yeah. Or I don't know. It's increasing and then it's decreasing. This is the multi, right? Yeah.
And they're 5.
Okay. So now today we want to find out the sublist, the longest sublist, which has this increasing and then decreasing. Okay. So, but if, for example, like that, okay, if this array is 2, 3, 1, and then 1, 3, 2, 2. Okay. Which sublist? You know, remember we talked about sublist. Sublist continuous. It has to be continuous. Subsequence or subarray, not continuous. Yeah. Sublist. How many sublists are there if this given this array and if this n element? How many sublists are there?
A lot.
How many? You can continue count it. If this, how many sublists?
6.
6. Yeah. Look, it's 1 plus 2 plus 3. Yeah. It's Cn1 plus Cn2. Remember?
Plus the end.
If it's 1, Cn1, it's one element. It's a sublist. Cn2, pick 2 sub index. Left and right. Okay. So that is n times n plus 1 divided by 2, and plug in the value 3.
66.
3 times
Is it
4
66?
divided 2 is 6. Okay. Got it?
66. 3 times 4 is 12. 12 divided by 2 is 66. I think it's 66.
Okay. Yeah. The value doesn't matter. But here now, the thing is that if we brute force the sublist, what's the time complexity?
Something.
Oh, look, how many sublists are there? How many sublists?
6.
Yeah, so if n equals 3, and then you need to tell me the sublist is n times n plus 1 divided by 2. So what's this?
N plus 1 divided by 2. Square.
Yeah, O(n) squared. That's what I'm looking for, yeah? If we brute forcing it, you take O(n) squared. So if we brute forcing all the sublists, and then check if it's sublist, if it's strictly increasing and decreasing, right? Let's going to take another n, right? So what's the time complexity if we're going for this brute force approach? Check every possible sublist.
O(n) square.
O(n) squared times if we have this sublist, we want to check if it's strictly increasing and decreasing. So what's the time complexity? What's the time complexity if we
O(n) square.
O(n)? O(n), yeah. So O(n) squared times O(n) squared times O(n), how much?
O(n) squared times O(n)
Cubic. Okay. Yeah, that's too slow, right? Yeah,
It's
that's
the
too slow.
slowest in the world.
Yeah, it's very slow. Yeah. So yeah, the brute force. Yeah, we got it. Try every possible sublist. That's going to take O(n) squared. For each sublist, we check if it's strictly increasing or decreasing. That's going to take another n times together O(n) cubic. That's too slow. So we can obviously do better than this, right? So how about?
Obviously.
Yeah, obviously. So look, if this is a sublist, look this one. Check this one. So how many parts can it contain? Does it contain? This strictly increasing. No. How many parts can you strictly increasing and decreasing? So how many parts does it contain? I mean, can we separate it into 2? 1 increasing, 1 decreasing. Remember? Yeah. So look, this one has 2 parts. 1, 3, 5, and then 5, 3, 0. Right? So if at this point we can calculate, we know that if we know that the maximum sublist increasing ending at this point is 3, right? Then we know it's 3, and the maximum sublist decreasing starting with this point is 3. So what's the number? What's the length of the longest increasing and decreasing using 3 and 3?
6.
You need to minus 1, right? Because look, this thing counted twice, right? Yeah? Yeah? Make sense?
3 plus 3 is that's equal to 5.
Yeah, that's equals to 5. Okay, so let's do this exercise. If we have 2 arrays, which is this one is for increasing, yeah, increasing, Let's say increasing, and let's the decreasing. So you tell me what should I put here, right? Look, increasing, ending at this point is 1, at the beginning is 1. What should I put here?
You shall put
What's the longest sublist that ends at here?
2.
2, and then sublist. Remember, come
3.
3
No.
ends at here.
Longest.
Yeah, longest. Sorry, ends at here. Where?
That is
So what value should I put here?
0. Oh no.
1. Because the single element is also counted as an increasing. Okay, here. Huh?
2.
2, and then
3.
4,
1.
and then
2. 1.
why is it yeah, and then Ryan, to get it? 2, 3,
3.
1,
1.
1. So this means that the longest sublist which ends at here, right? Look, why this is 3? Longest sublist is 1, 3, 5. Why this is 1? Because look, it's just 1. Yeah, makes sense? And then look at longest decreasing. But longest decreasing we compute from the backward. Yeah? Look, it's easy. For the increasing, we calculate from the left to the right. Why is it easy? We can make use of the previous value. Look, here is 2, right? And 5 is bigger than 3, so we know it's plus 1, 3. Am I right? Yeah? So longest decreasing. So if this is decreasing, this is 1, 1, decreasing, and then that's 2, right? And then that will be 1, 1, 2, right? Yeah? And what's this? What shall I put here? 3,
2.
2. Why is it 2? 1, 1, 2, 1. Okay, so and then at this point, at each point, we plus these two values minus 1, right? And we also have to consider if it's only single one. If this is like that, 1, 3, 5, 7, you need to tell me it's 0. Why is that? Because it only has the decreasing part. It doesn't have any increasing part, right? Yeah.
It does have an increasing part.
It doesn't. It has the increasing part. It doesn't have a decreasing part, right? Okay. Yeah. So we have to check if each element should be bigger than 1. So it has the increasing part, and also it should be decreasing part. Is the value should be more than for the decreasing part should be more than 1 because it has decreasing part. And if it's both satisfied, if it's bigger than 1, then we plus it together. Why should we minus 1 here?
Because we counted twice.
Yeah, this thing we counted twice. Okay, and then it'll be yeah. Let's implement it. Then it'll be. And then you just tell me, think about the complexity, okay? Time complexity for the time and the space.
Let me see.
Okay, let's do it. Define, let's say, longest increasing and decreasing subsequence, okay? Sublist. Nums. Okay, first of all, we get a length, the number of, yeah? So now we won't have two parts. Increasing, which is at the beginning will be 1 times n. Yeah, this is the array which has n element and it's filled with 1. Decreasing also is 1 times n, right? And then I start for I in range. I start from the second element to the n, right? If this element is bigger than the previous one, yeah, so then I can say, okay, increasing I or plus equal increasing what I minus 1, right? And then again, here is same. For I in range, I start from the second to the last. N minus 2 up to 5 minus 1, minus 1. If num I is bigger than nums I plus 1, right? So if it's bigger than that, then decreasing I plus equal decrease plus decreasing I plus 1, right? And then we have these two arrays. And then look, answer equals 0 at the beginning for I in range We can start from the second, yeah? Because the first one, can we start with the first one? No.
No.
We can start with first one, but it doesn't make sense, right? Because we always,
It makes us total dummy.
yeah. So we start with the second, yeah? Because look, 1, 3, 5, 3, 1. So is it here? Is it here? There's nothing before, right? Yeah, there's nothing before. So here, the increasing part will be 1, right? The decreasing part will be 1. Right? Because look, it has nothing in before. So increasing is always 1. But because we want to check here, if increasing I needs to be bigger than 1, right? Yeah, remember we talked about this. And decreasing needs to be also bigger than 1, right? To n minus 1 here. Then we can say answer equals max answer, and then increasing I plus decreasing I plus, and what should I do? There's something missing here.
Column
Increasing I plus decreasing I, and then what?
minus 1.
Yeah. And then return, there's something missing here. Return what?
Answer.
Yeah, answer. What's the time complexity if you look at this?
If I look at it,
There's 1, 4, but they're independent.
n.
On plus on plus on.
O2n.
3 on, how many?
O(n) cubic.
No, they're separate.
O3n.
O3n. So O3n, we drop a constant, right? Because
Okay.
this is always constant, so On.
Okay.
What's the space
I said
complexity?
O(n).
What's the space complexity?
One.
Not guessing, what's this?
And increasing and decreasing.
What are these? Now, there's a space we allocated, so
N
On
times.
2, right? So it's O2n is also On, right?
You said
O2n.
O(n), didn't you? Yeah.
Any questions so far, Eric, Ryan? You sure you understand this? So what? Okay, so in one word. Okay, I got 2 questions. So first of all, what did we talk about today?
About the longest increasing
And
sublist, increasing sublist, and then decreasing.
okay, perfect. What's the second question? How are we doing it?
Because we're using the increasing thing, and then
What's the increase? What does it store?
it stores the what's the longest
Before ending at the index, right?
and then
And
at
what's
the ending
decreasing?
is decreasing at the end. Go down. You start the end and then go.
The longest decreasing sublist starting with I with that place, right? Okay, and then why should we minus 1 here?
Because we use a number twice.
Use the second middle, yeah, twice, yeah, so we have the minus 1, yeah, that's very good. Okay, wait, don't do it. Yeah. Okay, so this is On. That On, the time complexity is optimum. The space complexity, there's O1 approach, but it's a little bit complicated. We can save it for the future, okay? Or you can think about it when you have time. The space complexity, we are using On, right? But I'm telling you that there's some approach which use O1 space, but still gives the On linear time, okay? Okay, that's it for today. Good job.
Bye.
Bye bye.